Fortigate SNMP integration, SolarWinds Network Performance Monitor versus PRTG. In this video, we will compare two of the most famous SNMP products. An SNMP is a famous network protocol that allows you to monitor network interfaces, network devices, and network services, and create metrics and incidents and track the performance over time. So SNMP is a very important component of any network infrastructure. And for this video, we will compare two of the most famous products, which are SolarWinds Network Performance Monitor versus PRTG, which is a free option with some limitation on how much sensors you can use in the free version. So let's see how we can integrate our Fortigate using different SNMP services. And starting with PRTG, you can install this in a local Windows environment. This is the main dashboard that you get once you install your environment. So first, the device will try to automatically auto-discover all the environment component in your network and creates alarms and different sensors automatically for you. For example, right now we see that we have 24 alarms saying down and 6 warnings, and 23 alarms are showing up status. So first, let's see what did PRTG discover so far in our environment and start configuring our Fortigate with our SNMP server. And under devices, we will see all the devices that PRTG was able to discover so far. If we take a quick look, our root device, which is the server that contained this installation, the 192.168.1.111, and we can see already that there are specific sensors or specific checks that have been configured automatically, like the core health of the device, the disk space alarms, the network monitoring. We also have an internet HTTP sensor, which automatically tries to communicate with the internet to make sure there is internet connectivity. Once we hover over any of our sensors, we can see an overtime graph of our uptime and downtime performance for this specific sensor. And once we go down, we can see here our on-premises firewall, the 192.168.1.99. We have already 8 sensors configured on this device, out of which 6 of them are showing in alarm state. So let's see what we have here so far. First, we have an IMAP and Bing sensors that are showing an up status. So this is just trying to probe the interface on the firewall to communicate on these services, and it's getting a good response. Now we are getting certain SSL certificate related issues on this Fortigate unit. And in this case, if we don't care about this SSL certificate, if we are not using this port, we can actually go under this sensor for SSL security sensor, and we can either acknowledge indefinitely, or we can pause this sensor, or we can completely delete this sensor. We can also multiple select all these sensors that we don't need and we can delete them. And now we only have Bing running, and if we check the Bing status, we see that we have 100% uptime. We can see that the PRTG is able to Bing this interface at all time, and we can even see details like the millisecond, the minimum, the maximum, and the average. And we can see all kind of nice graphs for this specific sensor. And now let's go back to our devices, and if we go down, we even see that our PRTG installation is able to probe the clients found on our VMware environment. So it's able to read the virtual machines inside the VMware workstation. And if you have vCenter or if you have Hyper-V, it's able to read these as well. But our concern now is to configure SNMP between the Fortigate and the PRTG. As we see, SNMP is part of the administrative access rules that we need to configure on each interface. For example, right now we only have Ping, HTTPS, SSH for management, and FortiManager access. We can also enable SNMP on this interface. So now to get the full functionality for our SNMP protocol, we need to go under our on-premises firewall first, and we can edit our device settings. We can change the name from this generic name to our on-premises firewall. And we can also go down, we can customize it with a new icon, We can also define our service URL. We can put the URL that launches our Fortigate GUI. So we can change this to the correct port we are using. And now we can configure our SNMP server, and we can use version 2. So we have to give it a community name, and we can call this our Fortigate community. And for the IP address, we need to define the IP address that is running our PRTG instance. So it will be this IP address. And we can accept queries and send traps to this IP address. So queries will be using port 161, and that's when PRTG is communicating to the Fortigate unit. And traps is the other way around. That's when Fortigate is sending SNMP traps to PRTG. It will use port 162. And those are all the different SNMP events that are included in the SNMP community. So it will send us information related to CPU usage, memory, high and low, VPN status, heartbeat status, and IPS antivirus related status. So this is going to be very useful for us to monitor and analyze our network traffic and our device health. And now we have our SNMP server configured. Now we need to do the same under our PRTG by going into our on-premises firewall. And if we go under Edit, Settings, we will see an option for SNMP devices. So we can turn off the inherit from network infrastructure, and we can configure it to use version 2, which is the recommended option. The community string or the community name, we change this to Fortigate on the Fortigate site, and this has to match. And the same for our port, we'll use port 161. And now, once we hit OK, now we have configured SNMP also on the PRTG side. And now we can install the Fortigate extension for PRTG. We can get all the sensors ready for our Fortigate monitoring. And once we download the PRTG extension for Fortinet, we can take all the files from the zip file and we can extract it to the PRTG folder. And now the files have been added to the PRTG folder. So we just need to come to our PRTG server and we need to restart our core services to take effect. So under administrative tools, we can restart our core server from here. And when the server comes back up, we can go to our firewall object again. And this time we want to right click on our firewall and choose auto discovery with template. And now we will see two new options for Fortinet, one for the Fortigate health and one for custom switch. We can hit OK, and this will auto discover the device using this template that we just installed in the PRTG directory. And then in a few seconds, our firewall will start having additional sensors added automatically. And inside we will see different metrics such as our CPU usage, our ping time. Now we can see different statistics from each core on the CPU on the Fortigate. We are also seeing a VPN alert that our VPN is no longer up. And we also see a sensor for Fortigate heartbeat. But we don't really have heartbeat configured on this device, so we can just come to this specific custom sensor and we can remove it from our list. We can remove the alarms associated with this. And if we refresh the page, now we are also getting additional alerts for our individual interfaces. We have our WAN 2 interface, traffic and internal traffic and LAN traffic. And if we go into one of the interfaces, we can see the speed that is going through the interface right now, what was the lowest value and what was the highest value. And we can see a graph over time for the bandwidth usage. Now let's go back to our alarms, and we are seeing this Fortigate VPN alarm because our status is down. So PRTG server sent an SNMP query to the firewall inquiring about that specific interface. And the firewall responded back to the SNMP server that this device is no longer up. Therefore, PRTG is alarming us in here and also in the global alarms that we are not able to reach this Fortigate VPN from our on-premises firewall. And here we can see the same. We can see the minimum, the maximum, the bandwidth, traffic, and charts for all our information. We can see historic data for this specific sensor for a period of time. For example, if we want to see last week and we do a start, This will show us a report directly for our status on the VPN for the past week in this generated HTML file, and it has timestamp for every day. So this is very useful to conform with SLAs and get a historical data of performance over your interfaces and services. But also PRTG comes fully equipped with a full incident response system. You can find this under the tickets system. But now we are just seeing informational data. But if we go back to our VPN failure, and if we try to configure a notification trigger, for example, if we add a state trigger, we can say if the sensor is down for at least 60 seconds, we can either send an email or push notification, or we can also open a ticket in our ticketing system. We can add this ticket notification for our VPN, and we just need to wait 1 minute and come back to see if PRTG was able to submit a ticket in our ticketing system. And now, after 1 minute, we see updated tickets notification in the top. And if we hit that, now we can see a ticket created automatically for us that says on-premises firewall VPN has been showing down. And if we go down, we can see that the time that the interface had gone down or reported down, and we can see which device is associated with this infrastructure and which group and which probe it has been using. And it shows us the total downtime and the total uptime. So now you can use this ticketing system to assign these tickets to your network administrator and say, please report tunnel or please take care of this incident. And it's going to show you your comment in the ticket like that. So other administrator can look into it and can see the history of the ticket. Now let's see how fast the system responds to changes in the interface settings. And now our tunnel is in up status. So if we go in here and we start watching the VPN sensor in our PRTG, in less than 10 seconds, the Fortigate VPN interface has been updated in the SNMP logs in PRTG, and now it's showing an up status. And if we go back in here, we can see the minimum is now down, but the maximum has been up, and we are actually seeing the traffic in and out of this VPN interface. So PRTG is very lightweight and very quick when it comes to incident response and monitoring for your interfaces and devices. Now if we go back to our ticketing system, we don't even see the ticket anymore for the VPN. So if we change the status from open to all, we will see that the default setting for PRTG is to close the ticket automatically when the issue gets resolved. So right now, if we check our ticket updates, once we ask our administrator team to reboot the tunnel, now we are see that conditions have cleared closing ticket automatically. So with PRTG, you can configure all kind of alarms and triggers, and you can configure the actions to email or open a ticket automatically in your ticketing system. And we are not just talking about interfaces. We can configure triggers based on CPU usage, or RAM usage, even for WAN traffic or LAN traffic. So we have all liberty to create all kind of monitoring system using PRTG, and it's highly recommended product. We can also do the same from our AWS account. We can configure our Fortigate on AWS to communicate with SNMP to this local on-premises PRTG server if we don't want to use the AWS built-in tools. And we can also do it the other way around, so we can configure our AWS CloudWatch to talk to SNMP server on-premises on our Fortigate unit, and we can use AWS CloudWatch to aggregate the logs in there and create alarms or SNS topics. And also if we check our email address, PRTG would be informing us with all these incidents and all these events by email by default, and it does not require any SMTP settings. It directly uses the SMTP settings configured on the device. So this is very useful to get alerted with all your information and forward all these events to your administrator email addresses so you can get a quick response and quick acknowledgement of network monitoring solutions. So now we have reviewed the main functionality of PRTG platform. And now let's see how we can configure the same from our SolarWinds platform. Once we set our password for the Orion system, we will be forwarded to this Orion configuration wizard for the first time. So now we can start outlining our network. And what this will do is it will ask us to provide either individual IP addresses or blocks of networks. So we can add our subnets by CIDR mask. So we can go ahead and add our first subnet 192.168.1.0/24. And we also running this instance on this 192.168.17 network. And now we have our two main networks. So we can go ahead and click next. And similar to PRTG, we are giving an option to add VMware or Hyper-V instance. And next we can define our SNMP credential. Similar to PRTG, we can use one of these, or we can just create a new credential and we can choose to use this SNMP community string. And now we have our SNMP configured on the SolarWinds, so we can go next. And optionally, we can use this to monitor Windows system by using a credential to get into Windows servers and Windows clients. And this will use WMI to collect information about the Windows host. So we just need to monitor the firewall for this specific instance. And in this step, it's going to ask us what is the default polling method that will be used with devices discovered in our network. So if you are using mainly Windows clients or Windows servers, you need to use WMI. And in our case, we are using SNMP, so we can keep this option to SNMP. And we can go next. And in here, we can define our threshold for our SNMP timeouts and Windows timeouts. So we can tune these to our needs. And for the final step, it's going to ask us how often do you want to run the discovery on the network. So we can do it only for the first time, or we can run it additional times to keep discovering more devices if we have a dynamic environment. But right now, we only need to do it once, and we're going to do this discovery now. So once we hit discovery, it will start sending traffic to both networks, as we see the 192.168.1.0 and 192.168.17.0, and it will kind of board scan these hosts to try to discover which operating system they run and which services are live on all these devices. So we're going to give it a few minutes until the discovery is done. And once the discovery has been done, our SolarWinds system was able to detect our Windows server running this SolarWinds instance and the Fortinet firewall with the logo. So we can go ahead and do next. And under our interfaces tab, we can see that the SolarWinds was able to detect even the interfaces on the firewall. For example, we see an Ethernet interface, and we have our WAN interface in up status. And WAN 1 interface is admin disabled, which is correct. And we can see the monitoring type is SNMP. We can also see in here our cloud, which is our VPN interface. And we can also see our LAN interface or our virtual interface. And it's labeled under transport bridge interface, but it's actually just the virtual interfaces on the firewall. We can go ahead and do next, and we will also be monitoring the RAM, the virtual memory, and the fixed disk on the Windows server. And once we go next, we have here our list for our discovered devices. So this is our Windows server, and this is our Fortigate firewall. And we can do import. And once this is finished, now we can see a summary of our network discovery. So we are running monitoring on 2 nodes, 3 volumes, and 5 interfaces. So let's go ahead and go to our Orion home. And this is the home page for our SolarWinds monitoring tool. First, we have all nodes. So we can see a block that contains all the nodes we are monitoring. And next, we see the alerts that are associated with our device. And we can see already a sensor that has been triggered automatically by the SolarWinds. We can come here and we can see when was this alarm triggered, how long has it been running for, and what severity is this belong to. We can come here and acknowledge this error and say this is a false alarm because we have internet connectivity, we don't have anything to worry about reaching Google. So the way we can acknowledge the alarm will shut down the alerts associated with this. So if we go back to our summary, now we no longer see this alert in here. Now let's expand our Fortinet node on SolarWinds. We see everything is showing up, but if we go down, we can see more information about our node. Our node is up. This is the manufacturing of the device. And those are the different interfaces on the device. So we have our WAN interface, our SSL VPN interface, our virtual interfaces, and finally our VPN interface. So all the interfaces we have right now are up. This node is actually showing as wireless controller, but this is indeed a Fortigate unit with wireless controller on it. We can see the main metrics like the response time. We can see the percentage of packet loss, CPU load, and memory usage. And we can see all these metrics over time on this bar. And when we go down, we can choose different options. For example, we can edit this node. We can rename the device to Fortigate, and we can modify our SNMP settings or anything that we need to modify in the specific profile, like add location information or add specific notes. And finally, we can submit. We can also request a new update for the metrics or rediscovery of the firewall configuration. We can SSH directly to the Fortigate using this built-in SSH client. And we can also use the performance analyzer, which is an add-on for SolarWinds NPM. And finally, if we are doing a maintenance on the site, for example, if we are moving cables around and expecting certain outages as part of our maintenance window, we can define this to mute alerts for a specific period of time so that we don't create incidents when a specific work is scheduled to go through in this time by going into schedule and choosing a defined window. And in this time, if there is interfaces going up and down or different traps are coming from the Fortigate, those alarms will be muted by the SolarWinds system automatically. Finally, if we go down, we will see our list of interfaces on the Fortigate unit, starting from our WAN interface, our virtual interface for SSL VPN portal, and our virtual interface for internal and for LAN, and finally our VPN interface with the cloud firewall. If we check any specific interface, for example our VPN interface, we can see the current bandwidth going on the interface. And if we go down, we will see a nice chart for our interface downtime. And as the time goes through, this bar will start filling up green from the right to the left. And it will be a very nice visualization to see the information about your interfaces over the last 24 hours or so. Now let's try to create an outage to see how fast will the SolarWinds detect the outage and report it to us. So I want to go ahead into my VPN and I want to break the VPN connection so this tunnel would come down. The tunnel had gone down right now. So if we come here and if we go back to our summary dashboard, and now finally in about 2 minutes, the SolarWinds was able to detect that a node is in warning or critical status on the Fortigate unit. And if we open this up, this alarm had been triggered and it's showing in critical status. Now if we look into the history of alerts on this node, we can see that the alarm had been triggered and then there was an attempt to send an email address. So this is alarming us that the node Fortigate is in warning and it's showing us all this information, but it doesn't focus on the interface that is going down. In other words, I don't see any single events in here that mention that the cloud VPN is down. I'm seeing an indication that maybe the whole firewall is going down. So this is not ideal for us. If we want to monitor our network traffic, we need more details about our information. And now let's go back to fix our VPN interface and see how long would the SolarWinds take to detect this change in status. And after about 1 minute, now the Fortinet is showing an up status. And if we check our Fortigate again, and we go down to the interfaces, now we see the cloud interface is back up. And if we check on this interface, now we can see the time that we got the outage over time and when was the service come back up. And also in this bar, we will see the green areas for connected and then the red areas for the time where we had the downtime. This is very nice visualization, and when you have data from many weeks, this will be very nice to run a total analysis on the health of your device and the health of your interfaces. Now finally, from our SolarWinds, we can go under dashboard and we can see the top 10, and in here we will see different metrics related to our infrastructure in total, including interfaces rated by bandwidth, our CPU load and memory load by device. So this is an overall nice picture of how the system can gather data from a lot of different types of devices and collect it together and do analysis on it. And we are seeing all this data just from 2 devices. So if you add all your network devices to this monitoring system for a period of time, you will be able to gather a lot of intelligence data and a lot of metrics to monitor and analyze your devices and the health of your systems. And now to wrap it up for the comparison between SolarWinds and PRTG. And with SolarWinds, we see advantage when it comes to easy integration with a lot of devices, including a lot of enterprise devices from different companies. And also it's able to integrate natively with the Fortigate with the built-in database without having to import the MIP file. Also, the SolarWinds has a very nice design and layout, so it stands out when compared to PRTG when it comes to design. Now, when it comes to disadvantage of SolarWinds, they do not allow you to import any MIPs. In fact, you have to contact their support system, and if they agree to the changes you are proposing, they will include this MIP in the global database and release it in the next update. Also, this is very heavy application, as SolarWinds download a SQL server, MQ server. It comes with tons of utilities and application you can run directly from the Windows server, like analysis, diagnostics. But the main disadvantage we see with SolarWinds is it's slow to respond to network outages and recovery. This is the main point we are using SNMP for. We need a program that is able to quickly notify us of serious and critical issues. We are talking about a few second notification at max, if not sub-second. And also the alerting has a major flaw because it doesn't show us the interface name that is in problem. So imagine you have a big Fortigate device with 32 different interfaces, and you get this alarm that is showing a misleading title that the whole device is down, but in fact you have to go inside the device and you have to look which interface out of the total 32 interfaces. You have to see which interface is down, which is kind of inconvenient. Now, on the other hand, for PRTG, we actually have a free version with limited number of sensor support. Also, this is a much lighter application than SolarWinds when it comes to size or when it comes to the component that come with it. And best of all, it's very fast to respond to network changes, a lot better than SolarWinds. And an extra point for having a built-in ticketing system, so you don't have to use ServiceNow or other help desk solution, at least in the beginning phase. And the disadvantage to PRTG is that we have to install the Fortigate MIP manually. And also we would not have the full support for all kind of devices such as SolarWinds. So this is the comparison between SolarWinds and PRTG. In this case, PRTG wins the comparison because it provides much faster connection time, much lighter application, and acceptable and nice design as well. So our choice is to use PRTG for network monitoring. Thank you for watching.